So the planet Neptune, I should have mentioned in one of my earlier two lectures about Neptune, is that when it was discovered, it had this distinctly blue color to it, and people think of the ocean as being blue. And so they decided to name it after the god of the sea, Neptune. The planets, Jupiter named after the king of the gods, Saturn slower, moving around the sky, so they thought, they named that after Saturn, which was the father of Jupiter in mythology. Uranus would be the father of Saturn in mythology, and so Uranus was the next one out when that was discovered. But then there was no father of Uranus, so when they discovered Neptune, they had to name it something else. And so they weren't really sure exactly what to call this, but the blue color suggested naming it after Neptune. And then the symbol for it, of course, is a trident in the symbol of planets. So we're trying to figure out why Neptune and Uranus are so much alike but so different. Uranus is just a plain blue world, or a bluish, greenish world that is almost featureless. It radiates the same energy it gets from the sun. It's so far from the sun that solar heating doesn't cause just an enormous amount of atmospheric effects. All the methane in there acts as a very powerful greenhouse gas, keeps it at a pretty much steady temperature, day, night, winter, summer, and so forth. There is some kind of circulation on the inside that carries the heat around between the sunlit side and the non-sunlit side, but other than that, Uranus seems pretty uninteresting to look at compared with some of the other worlds we've talked about. Neptune is way different. Neptune is about the same size as Uranus. It's slightly more mass, so that means it's a slightly more compacted, and it's very active. We've got supersonic winds. We've got amazing storms that come and go all over the place. Even that great dark spot, is a giant hurricane type storm. Unlike the great red spot on Jupiter, the great dark spot on Uranus comes and goes. Jupiter's storm's been there pretty much steady. This world is so dynamic. The storms don't last forever. They come and they go, because the Hubble telescope was able to eventually see Neptune well enough to see, that you've got that the storm was there and then it went away, and then another storm appeared, later. And so we see that it's very active. The key is most likely that Neptune radiates more energy than it gets from the sun. And so that seems to be the key. Now, why does it do that? Okay. Interior structure of these two worlds is pretty similar. The only thing that Neptune has going for it that's different is the core is a tiny bit bigger, probably, and that means the extra gravity is able to squeeze the atmosphere a little bit tighter. It does have a little bit more methane in the atmosphere than did Uranus, but that seems to be about the only kind of differences that are there. Now, the key to what's happening in these worlds is almost certainly going to be all that methane. Methane is CH4, so it's a carbon with 4 hydrogens. Ultraviolet light hitting that methane can actually break it down into carbon and hydrogen. Now, if a giant impact happened on Uranus, it would throw a lot of methane up into space around the world, and then the UV light would break it down. All that carbon would settle on the rings and moons. That would explain a lot of why it's so dark with a very low albedo in the entire Uranian system. But some of that carbon stays in the atmosphere. And so just a few years ago, 2017, they did experiments in the laboratory to try to reproduce the sort of temperature and pressure that you get inside Uranus and Neptune. What we found was that we can actually produce liquid carbon when we do that. Now, why is that important? Well, liquid carbon is really weird. You don't normally get liquid carbon. On Earth, carbon is typically going to be a solid or it can be a compound mixed with something else. If liquid carbon is unheard of on Earth. I mean, in theory, if you heat carbon up enough, you can vaporize it into a vapor. You know, everything you can vaporize if you get it hot enough. Making it liquid involves very high temperature and very high pressure. And so that's kind of an unusual situation, but it does apparently exist in Uranus and Neptune. Liquid carbon has some interesting electrical properties, meaning it conducts electricity in an interesting way that is going to be quite possibly the reason that these worlds have weird magnetic fields. Electric current, electrically conducting things interact with magnetic fields. So these two worlds, not only having this big salty mantle, but also having this liquid carbon, might be why their magnetic fields are so weird. Now, this is an area of current research. We don't know this for sure, but this is an area of current research that suggests that maybe this carbon is part of what's happening in there. Okay, well, that's not the only place that carbon comes in. So the carbon does something else interesting in the atmosphere, and that is that Neptune, being a little bit more massive, a little more compacted atmosphere, it's just right so the carbon can actually form into little small crystals in the atmosphere. And then as the crystals grow, gravity causes them to fall lower into the atmosphere. And so as they fall, then falling from upper to lower levels, they release gravitational energy, which then heats the world. Okay, so that is believed to be one of the possible sources for heating in Neptune. All right, so remember, Jupiter releases more heat than it gets from the sun, in part because of the Kelvin-Helmholtz contraction, squeezing the planet, letting it generate heat in that fashion. Saturn probably has a little bit of Kelvin-Helmholtz contraction, but also the helium rain produces heat as the helium droplets of liquid helium form and rain down into the interior of the world. That releases gravitational energy that also ends up heating the world a little bit. And then Uranus is just boring. It doesn't really do either of those things. And then Neptune does not do Kelvin-Helmholtz contraction, certainly not to any great extent. Does not do helium rain. Doesn't have the conditions necessary for that. But it does have this sort of like diamond sleet or hail. You know, it sounds kind of cool. Hailing diamonds, or really it's more like sleeting diamonds, is how it's actually being produced. And so that is generating heat as it's falling. So that's one reason, perhaps, that Neptune radiates more heat than it gets from the sun. And so this is just speculation at this point. It has not been proven. Again, only one spacecraft has ever been there, the Voyager 2 spacecraft, and did not have the instruments to really measure this, and was not there for very long anyway. So Uranus and Neptune, both of them we know very little about, because they are so far from the sun. They're very difficult to study even with our best telescopes in orbit around the Earth or on Earth. So they're very difficult to study from here. They are also very difficult to study from space, simply because they're so far from the sun that the sunlight's so weak there that they are so cold and so dim that you have really long exposure photographs to see anything. And it takes a long time for signals to make it back, and they're not very strong signals when they make it back either, because they've been dissipating for so long. And so this so far and so spread out. So that makes these very difficult worlds to study. And so to that end, it would be wonderful if we could send more spacecraft out to the outer solar system and study these worlds. So far, that's not in the plans, but it would be really nice if it were.